This last part of the lecture is just about the behavior of polynomials as they approach plus or minus infinity. And as you might guess, if I have a polynomial which looks like this, the highest power is x to the n, and the coefficient is an. And the limit as x approaches infinity is the same as the limit of the term with the highest power. So it's the limit as x goes to infinity of an x to the n. Now the x to the n will go to plus infinity, but the an might be negative, in which case this leading term would go to negative infinity. And as x approaches negative infinity, then again the polynomial behaves like the leading term, and the limit as x goes to negative infinity is the limit as x goes to negative infinity of an times x to the n. And the x to the n might go to plus infinity if the n is even, or it might go to negative infinity if the n is odd. And again, you have to be careful about whether the coefficient an is positive or negative. So let's try a few examples. The limit as x goes to infinity of x to the 4 plus 2x plus 1. This is equal to, according to this outline, the limit as x goes to infinity of x to the 4, and there's no an here, the an is 1, so this is just plus infinity. And the next one is the limit as x approaches negative infinity of this polynomial where the leading term is 2x cubed. And it's equal to the limit as x goes to negative infinity of the leading term here. And as x approaches negative infinity, x cubed goes to negative infinity. And the 2 is positive, so it doesn't change the sign of that. So this limit is negative infinity. And here's another polynomial. And again, when we calculate the limit as x approaches infinity, we can just restrict our attention to the leading term and how it behaves. And this is the limit as x approaches infinity of negative 3x to the 5. Now, we're going to plus infinity, so the x to the 5 goes to plus infinity, but here we're multiplying the term by negative 3, so this goes to negative infinity. And for this one, to find the leading term, well, it's enough just to concentrate on the x values here. So this is the limit as x approaches infinity. The leading term here is what I get when I multiply the highest powers of x in the expansion of these linear factors to the various powers. So this is x cubed times x squared times x to the 5. So it's the limit as x approaches infinity of x to the 5 plus 5, which is 10, and this, of course, is plus infinity. And this is just a reminder of the shortcut we can take with rational functions. If I have the limit as x goes to plus or minus infinity of some polynomial divided by another polynomial, again, I can restrict my attention to the limit of the quotient of the leading powers of the two polynomials.